Welcome back, class, for your next note video. Today we're going to be focusing on lesson 1.4, solving equations. And our objective today, we're going to be working to solve equations and solve problems by writing equations. Now, hopefully from Algebra 1, you remember the steps into solving a linear equation, all right? Now, the first thing I always do, and you can reference it right above my smartboard, because I have all these steps labeled out right there. Now, the first step, I want to clean up the first side of my equation. Before I start crossing the equal sign, I want to clean up each side. So here, what I'd like you to notice is, when you see these parentheses, I want your first thought to be, I can distribute that -4. When you see parentheses like that can always be your first thought. Cleaning up, you're going to be distributing, and then combining like terms, all right? So when I distribute that -4, -4 times x is -4x. -4 times -2 gives us a positive 8. So again, step 1 is clean up by distributing. Next, we're going to clean it up even further by combining like terms. Notice, now I have this 10 and 8 there. So again, I want to get those together. I'm just going to call that 18. I still have my -4x equaling 22. So now I've cleaned up the side of my equation. It's as simplified as it'll get. So now I need to start crossing the equal sign, okay? So the first thing I want to do, I want to gather the constants, the pure numbers, away from the variables. So what that means, I want to get this 18 over here with this -22. Now, in order to cross the equal sign, you have to do the opposite of what you see. So notice that is a positive 18 there. So what I want to do, I'm going to subtract 18 from both sides of my equation, because it'll cancel it off of that side and bring it over to my other side. -22 minus another 18 will give us a -40. Now, I need to cross the equal sign again. Now, I have -14, which is multiplying my x. So in order to undo that, I'm going to have to end up dividing by that -14. So I'm going to show dividing both sides by -14. Cancels it over here, getting my x by itself. And now -40 divided by -14. When you type it into your calculator, it's going to give you a pretty nasty number, okay? Your calculator is going to spit out something 2.857, blah, blah, blah. Now, instead of giving me that, if you know how to do this, and if you don't, you can always come and ask me. Have your calculator turn that back into a fraction for you. You can command your calculator to turn it into a simplified fraction, and it should give you 20/7. And that'll be the simplified answer. That is what I'm ideally looking for. All right, moving on to our next example. So, for our next example, last time when we saw those parentheses, we distributed, which in this case you could. You could distribute that 2/3 throughout. Now, what I want you to realize, though, that is going to give you some pretty nasty fractions, okay? It would work. It'll get you exactly where you need to go. But you're going to get some pretty nasty fractions that way. So, instead of distributing that, I'm going to do something different. Notice, this whole side of the equation is multiplied by that 2/3. So what I'm going to do, I'm going to do the opposite of that. See how this 3 is basically dividing the whole side of the equation? I'm going to multiply both sides of the equation by 3. So I'll still have the 2 over here with the 5x plus 7, but I'm multiplying the 3 over because it was encompassing that whole side of the equation. Now, you probably guessed, what am I going to do with that 2? Well, since it's multiplying the whole side of the equation, again, you could distribute it through, or more easily, I'm going to divide both sides of the equation by 2. Okay, so just to recap, what I did here, I multiplied by 3. What I did here, and divided by 2. The only reason I could do that is because it was encompassing the whole side of the equation. Otherwise, again, your first natural thought may be to distribute. That way you get fractions, completely doable. You'll get to the right answer. But I'm just showing you another way that you can undo that 2/3. Now, we're right back where we were at the end of the other problem. Now we need to start thinking about getting the constants away from the variable. I'm going to gather the constants on the other side. Okay? So C is positive 7 right there. We need to move that to the other side. Since we're crossing the equal sign now, that means I'm going to end up subtracting 7 from both sides. So I'm going to be left with 5x equals 20. Now again, I need to get that 5 away from the x now. Now, it is multiplying my x, so this time to undo multiplication, I'm going to end up dividing by 5 on both sides. And goes to the 5, so you end up with x equals 4. So this time we got a nice answer. So, please make sure you have this completely down, and I'm going to move on to the next slide. Now this one is getting a little bit more complicated still. Now, remember, for that first example, I said before we start crossing the equal sign, if possible, clean up what's happening here, okay? This time what's happening, I'm noticing this parenthesis, and then I can distribute that -2. And this time I have to distribute because it's not encompassing the entire side of the equation, it's only encompassing part of it. So I'm going to distribute that -2 through the equation. So -2 times 2x will give us a -4x. -2 times positive 3 gives us a -6. All right, now again, the second step in cleaning up our equation is combining like terms. I've distributed, now I'm going to combine the like terms. So I have 6x minus 4x. So over here, I still have the same thing, 5 plus 2x. 6x minus 4x. Combining those like terms gives me 2x. Right, now I'm left with that. Now this time I have a choice where I want to gather my variables, okay? My variables and gather my constants. So there's no right or wrong way to do this. You just get to take your pick. So I'm going to focus on this 5. I want to move that 5 away from that x. So I'm going to subtract 5 from both sides. So I've removed the variable from the, or removed the constant from that side of the equation. Next, this is the case, we have the variable on both sides as well. So once you gather the constant to one side, you're going to gather the variable on the other side. So here I see a 2x I have with the constant that I'm gathering. So I'm going to subtract off that 2x. Now, something very interesting happens here. When I subtract off that 2x, it ends up completely canceling my variable on both sides. My variable is completely gone, and I'm left with a nonsense statement. Now, from Algebra 1, you may remember, if the variable ends up canceling off from both sides, we're going to call that a no solution, NS. All right? There's nothing you can put in that equation. There's no x you can put in that equation in order to make it true. Now, I'd also like to review with you the flip side of that. What if, at this point, you had solved it, and you got something like this? Your variable canceled off still, but let's say you got something where both of them are the same number. That is something that is always a true statement. So if this were to happen, it didn't in this case, but if it were, I want to just refresh your memories. That is infinitely many solutions, okay? So for this one, we got no solution. But over here, this is just to recap, what would it look like to get infinitely many solutions? That's when the variable cancels off, and you're left with a true statement, 2 of the same number. Now, not only are we working with the skill of solving equations, we're also working on writing equations. So let's take a look at this. The length of a rectangle is 2 more than 3 times the width. If the perimeter is 60, what are the dimensions of the rectangle? So I'm going to draw myself a little picture here. I'm going to sketch a picture of what does this rectangle look like. So the length is 2 more than 3 times the width. All right, so we have to find the length given what the width is. So we don't know the width though. So I'm just going to call it W. Now we have to find an expression for the length. And what do we know? It's 2 more than 3 times that width. Well, now we need to pull in the skills we worked on in the previous notes, okay? We need to turn that into an expression. So, 2 more than 3 times the width. Well, that means we're going to start with the width. 3 times the width. 3 times W. We want 2 more than that. 2 more than that, we're going to be adding 2. Right, so whenever you see something like that, again, it's easier, sketch a little picture for yourself, because then it's easier to see how can I translate those words into my algebraic expression. And now what it's asking for is to find those dimensions. And it gives us the perimeter. The perimeter is 60. Well, thinking about a rectangle, hopefully you recall from geometry that the perimeter is the entire way around a shape. So what we're looking for is the entire way around, and I apologize, that should be a 3, the entire way around this rectangle. So we need to add up all the way around. So W plus the W plus 2, another W, and the 3W plus 2 again, and it tells us that equals 60. So we add up every side length, giving us 60, which we know is our perimeter. Now, we can use this equation to solve for W to find the width. I don't see anything I need to distribute. I don't have any of those parentheses. But I do see some like terms I can combine to clean up this equation. I want you to notice all of these W terms. So I have 1 W here, 3 there, 1 there, 3 there. 1 plus 3 plus 1 plus 3. That's going to give me 8 of those W's. Next, I see some constants. 2 plus 2. Well, that's going to give me 4. And it's still equaling that same 60. We have not crossed the equal sign yet. So we're done cleaning up that side of the equation. Now what we need to do is cross over that equal sign. So remember, first we're going to move the constant. We're going to move the number away from the x. So I have a positive 4 here. Now that I'm crossing the equal sign, I'm looking to undo that 4. So I'm going to subtract 4 from both sides. So I'm going to have 8W equals 56. I need to get the 8 away from the W now. So the 8 is multiplying my W. I need to look for how to cancel that off. Well, to undo multiplication is division. So I'm going to divide both sides by 8. So the width is going to be 7. So the width is 7. Now, remember, it wants both dimensions of the rectangle. So even though we have that, that's not quite the end of our problem here, okay? We also need to find the length. Well, thankfully here, if we have the width, we can use that to find our length. So now we just have to plug 7 in for the W, and that'll give us the length. So 3 times W, which is 7, plus 2, if we calculate that, 3 times 7 is 21, plus 2 more, that means that the length is going to be 23. And that is the end of our problem, all right? So, there is the end of our problem. If you have any questions, please bring them back to class to ask me tomorrow. Otherwise, thank you for watching, and I look forward to seeing you for our next note video.